Welcome back. In this segment, we'll examine the original functions of cortical areas involved in speech. This area represents words. We show a word's pronunciation with letters and special symbols between slashes. For example, rabbit. The semantics area represents meanings not in terms of words. For example, bunny and rabbit are two different words with the same meaning. When we prepare to speak, we start with some meaning that we want to convey. This area helps convert the meaning into a sequence of words. Next, we'll discuss how the words are converted into muscle commands for speech. A word is made up of syllables, and syllables are made up of phonemes. For example, pan is one syllable consisting of the phonemes p, a, n. Phonemes are important in learning to read, so we will talk about them quite a bit now. In the brain, each phoneme corresponds to a bundle of phonological features that specify how the phoneme is produced. For example, let's consider consonants. A consonant is produced by using some part of the mouth to obstruct airflow. Every consonant can be specified by three features. The place feature specifies where in the mouth the obstruction occurs. The manner feature describes how the air flows. The voice feature specifies whether the vocal cords vibrate. Next, we'll go through examples of these features for various phonemes. The point here is to get a feel for how phonemes are represented in the brain before someone learns to read. It will not be important to remember the details. For example, the phoneme b is produced by closing the lips to stop airflow. So for b, place equals lips and manner equals stop. If you put your hand on your throat and say b, you will feel your vocal cords vibrate. So voice equals yes. The phoneme p is produced in the same way as b, but without vocal cord vibration. So p has the same place and manner features as b, but voice equals no for p. Like p and b, the phoneme t is also produced by stopping airflow, but for t, the tongue is brought to the ridge of the mouth to do so. So t corresponds to place equals ridge, manner equals stop, and voice equals no. Like t, the phoneme n is also produced with the tongue at the ridge of the mouth. But for n, air flows steadily through the nasal cavity. So n corresponds to place equals ridge, manner equals nasal, voice equals yes. In the brain, this area represents phonological features. So some neurons are tuned to voice equals yes, others are tuned to voice equals no, and other neurons are tuned to other types of features, such as place equals lips. For example, the phoneme b is specified when neurons tuned to place equals lips and to manner equals stop and to voice equals yes are all active together. Connections between words and phonological features specify how words are pronounced. This area translates the phonological features for each syllable into the motor commands that produce spoken syllables. The motor commands go out to the spinal cord and then to the muscles that control the mouth, tongue, and vocal cords. This pathway between the posterior and anterior phonological areas also supports verbal working memory, which is what you use when you repeat something over and over to yourself. Verbal working memory corresponds to a loop of activity between these areas. Now we'll talk about understanding spoken language. Auditory input from the ears enters the cortex here in an area called A1. Even though phonological features are related to speech production, the auditory system breaks speech sounds down into phonological features. The sequence of phonological features activates words. These areas represent the meaning of the speech. So speech comprehension uses many of the same cortical areas as speech production. When you listen to speech in noisy conditions, it is helpful to observe the speaker's mouth movements. For example, the phonemes and n share the same voice and manner features, so they sound quite similar and can be easily confused. However, if you're looking at the speaker, you can see whether the sound was produced with the lips together for or with the lips open for n. So the visual input provides direct information about the place feature. Combining visual and auditory information to interpret speech is called audiovisual speech integration, and it is performed in this area. Neurons in this audiovisual speech area link observed mouth positions with the corresponding phonological feature. For example, the neuron shown as a black circle in the audiovisual speech area links neurons tuned to seeing lips together with neurons tuned to the feature place equals lips. To summarize, the take-home message of this segment is that processing of speech sounds is based on phonological features, syllables, and words, and that the audiovisual speech area links visual and auditory aspects of speech. This completes our summary of the cortical areas used in spoken language.